Recently, I've been attempting to formalize a mathematical model for the as above, so below physics I've been describing in these videos. And recently I put together a geometric framework along these lines capable of modeling gauge theories like particle physics and the gravitational dynamics of curvature. Here's the overview. Take a 4D Minkowski spacetime and define a constraint on all spacetime boundaries where the information within the boundary projected onto the boundary and the information outside the boundary projected onto the boundary are reciprocal. Basically, it's an as above, so below constraint that, according to Grok, successfully reproduces Yang-Mills and linearized Einstein equations. I've linked a paper in the description that lays out the proofs. It makes sense to me, but it's hard to get anyone to look at a paper nowadays, especially one assisted by AI, so anyone who's interested, feel free to check it out for yourself. As far as the intuitions behind the theory, this all started for me 5 years ago with Jordan Peterson and Eric Weinstein, which is probably an unexpected combination. But Peterson explaining conscious perceptions as layers of narrative about chaos and order, and Weinstein's explication of geometric unity as an attempt to geometrize gauge theory seemed like a solution and a problem. I didn't understand gauge theory well, but I understood the idea of dynamics, or of information, sitting on top of each other, gauged by each other. So I thought, layers of chaos and order, that's basically layers of entropy regulation. Then in a wild spark of inspiration, I wrote up a paper that is crazy. But it's where I first talked about the idea of using two relative entropy statements comparing three variables to talk about harmony between layers of information. Since then, this perspective opened me up to a lot of ideas I never really took seriously before. The idea of the universe being made of layers of stories, of emanations of patterns from above, that's the mystical worldview. But I should probably ground that back to the math I'm presenting. A scale invariant boundary constraint, like the one in this framework, is basically a way to talk about events in general, at all scales. Spacetime boundaries are like a narrative. They have a spatial component, a setting, which may or may not change across its time component, which is the story. You can imagine the boundary around you extending back to your birth, extended to your death, is the story of your life. And here's what's cool about biological stories in this framework. Biological organisms act as semi-local solutions, concentrating relational dynamics because they're general microcosms of the environment. The life of an organism is like a region of space-time where all the scale-invariant constraints on all the field layers are harmonized, because in addition to the conservation of the individual symmetries, defining the individual fields on all possible boundaries and on all possible scales, the organism evolved to preserve the harmony between the information within its specific boundary and outside its specific boundary. It evolved to harmonize with its environment more macroscopically. For the story of a particle, this just looks like conservation of momentum, charge, and other properties, each by their own scale-invariant boundary constraint. But organisms harmonize all of these constraints at the boundary defining their lifetime. Now, here's where the new physics comes in, because really so far this is just a new way to model old physics. In this framework, the unpredictability of quantum mechanics arises because standard quantum mechanical measurements omit the relational momentum of a particle with the rest of the universe. So our constraint frames wave function collapse as like a type of information truncation process. In other words, the constraint determines quantum collapses. The constraint is attracting the collapse of states towards outcomes that make for better microcosm to macrocosm solutions. But the relationship between any given particle and the rest of the universe is quite aptly compared to throwing dice, resulting in apparent randomness. But remember, this constraint localizes around biological organisms specifically. That means at the quantum collapse level, processes within a biological system would be attracted towards macroscopic complementarity at the quantum level. Not only would this enhance Darwinian evolution and explain gaps in evolutionary biology, but this localization of relational processing clearly corresponds to the individuation of consciousness in theories of a conscious universe. Biological organisms at the whole organism level participate directly in the most fundamental level of physics in the universe, inertia. Anyway, that's my argument for free will. Links in the description.